In this video, I am going to solve the problems from chapter Rotational Motion. First question. A point on the rim of a wheel of radius r which is equal to 0.165 meter rotates through an angle theta which is equal to 2865 degree. What is the linear distance s traveled by the point? So you have to see the picture here. The radius is given, the theta value is this one, and we are going to find the value of s. So for this, we have to use the relation between the linear displacement as well as the angular displacement, which is given by the equation s which is equal to r theta. This is the relation. Now, before we substitute the value in this equation, I have to convert this degree in terms of radian. So before we go for this question, I have tried what is given in the question. In the questions, they gave the value of radius, which is equal to 0.165 meter, and the theta is 2865 degree. So now what I'm going to do, I'm going to convert this degree in terms of radian. For that, we have to use the equation, the relation 2 pi radian, which is equal to 360 degree. So theta value is given as 2865 degree. I have to convert in terms of radian. So 2 pi radian over 360 degree. Now I have to use my calculator. 2865 multiply by 2 multiply by pi value. Here pi is 3.14 divided by 360, which give the value of 50. What's the value? 50.0 radian. Now I'm going to take this value, I'm going to substitute the value in this equation. S, which is equal to, what is the value of R? 0.165 multiplied by, what is our theta? It's exactly 50 radian, which gives you the answer of 50 multiplied by 0.165. The answer is 8.25 meter. 8.25 meter. So this is the answer for the first question. Clear? Second question. A soccer ball of radius 10 centimeter rolls on the grass for a distance of 31.4 meter without slipping. That means you have a ball and that ball has the radius 10 centimeter and which is rolling on the ground. So it covers the distance of 31.4 meter. How many revolutions has the soccer ball rolled? So we are going to find the theta again, but this time we are going to give the answer in terms of revolution. Clear? So that means the answer we are going to get in terms of radian, and we have to convert the radian into revolution. Clear? So for that, first of all, I'm going to write what is given in the question. Diameter of the ball is given. What is the diameter? Diameter of the ball, d, which is equal to 10 centimeter. So if you want to find the radius from the diameter, or which is equal to diameter divided by 2, by that 10 centimeter divided by 2 gives you the answer of 5 centimeter. So you have to convert this 5 centimeter into meter, which is nothing but 0.05 meter. So you have to divide this number by 100, and that number is nothing but in terms of meter. So this is our radius. Now we have to use the same relation s, which is equal to r theta, but this time we are going to rearrange this equation in terms of theta. So therefore theta, which is equal to s over r, I'm going to substitute the value here. So what is the distance covered? The distance covered here is mentioned as 31.4 meter. So I have to substitute the value of this s as well as r here. So what will be the answer? S, which is equal to 31.4 meter divided by 0.05. So what will be the answer? 31.4 divided by 0.05 gives you the answer of 628. What's the answer? 628 radian. Now I have to convert this value in terms of a revolution because the question, they need the answer in terms of revolution. So what is the relation? 1 revolution, which is equal to 2 pi radian. I'm going to use this relation for converting radian to revolution. So theta, which is equal to 628 radian. I'm going to convert this radian in terms of revolution. So how I can write the equation? 1 revolution over 2 pi radian. So by that, radian get cancelled with this radian and you will get the answer in terms of revolution. So take your calculator. 628 divided by 2 multiplied by pi value, which is nothing but 3.14, gives you the answer of 99.9. 99.9 revolution. So better I can just rounded this value. Therefore, theta, which is equal to 100 revolution. Clear? Third question. The third question is related to the wheel and the diagram is given here. So let's read the question. First of all, we have to identify what is given in the question, and after that we have to go for finding the answer. So first of all, I am going to read the question. A car wheels rotates at an angular speed of 0.06 radian per second. Its speed is then increased. That means this is your initial angular velocity, and after that the speed get increased. So what is the final angular velocity, which is nothing but 2.2 radian per second at an angular acceleration of 0.70 radian per second square. So what are the things given in the question? In this question, they gave the value of initial angular speed, so which is nothing but omega I, that is initial angular speed 0.06 rad per second. And what is your final angular speed? Omega final, which is equal to 2.2 rad per second. And also they gave the acceleration. Which acceleration? Angular acceleration alpha, which is equal to 0.7 radian per second square. Now what you are going to find the angle through which the wheel rotates before reaching its final speed. So that means we have to find the value of displacement, which is nothing but angular displacement we have to find, which is nothing but delta theta we have to find. So for that, we have to use the equations of motion with constant acceleration. Which acceleration? Angular acceleration. So we studied these three equations. First of all, I'm going to write the three equations. What are the three equations? Omega final, which is equal to omega initial plus alpha t. The second equation is delta theta, which is nothing but the displacement, which is equal to omega initial multiplied by t plus half alpha t square. And the third equation is omega final square, which is equal to omega initial square plus 2 into alpha into delta theta. So for that, we have to identify which equation is exactly easy for getting the answer. So if you want to use the first equation and the second equation, you need the time value. But in the question, there is no information about the time. So I think the third equation is the suitable equation for getting the answer of the displacement delta theta. So I have tried the third equation, omega final square, which is equal to omega initial square plus 2 into alpha into delta theta. And I have to rearrange this equation. So first of all, I'm going to keep this term here. I am going to move this term to the left hand side. By that, what will happen? Omega final square minus omega initial square, which is equal to 2 alpha delta theta. Now I'm going to keep this term here. I'm going to move this term to the left hand side of the denominator. So by that, your equation will become omega final square minus omega initial square over 2 multiplied by alpha, which is equal to delta theta. So now I'm going to substitute the value. So what is our final angular speed? So better I can write it here. What is our final angular speed? 2.2 square minus 0.06 square divided by 2 multiplied by the angular acceleration is 0.7, which is equal to delta theta. So what's the answer for the delta theta now? Use your calculator. 2.2 square minus 0.06 square divided by 2 multiplied by 0.7. So the answer I got is 3.45 radian. So what's the angle? 3.45. Clear? So this is the answer for the third question. Fourth question. Fourth question has two subdivision. So we have to read what is given in the question first, and after that we have to go for solving these two subdivision question. Okay. An electric motor rotating a workshop grinding wheel at a rate of 100 revolution per minute. That means its angular speed is given in terms of revolution per minute, and then the motor is switched off and came to stop. That means initially the wheel has the initial angular speed of 100 revolution per minute. After that you turn it off the switch. What happened? The wheel comes to stop. So that means the final angular speed is equal to 0. And if the wheel has an angular acceleration of magnitude minus 2 radian per second square, how long does it take for grinding wheel to stop? That means we have to find the value of the time in the first question. So before that, what I'm going to do, because we have to convert the value of the revolution per minute in terms of radian per second. So what I'm going to do, first of all, I'm going to write what is given. So what is given here? Omega initial is given, which is 100 revolution per minute, and the final angular speed is 0, and the acceleration value is given as, angular acceleration is given as minus 2 rad per second square. So now what I'm going to do, I'm going to convert this initial angular speed in terms of radian per second. So what I'm going to do, initial angular speed, which is equal to 100 revolution per minute. So I have to convert this revolution in terms of radian. So how I can convert? 2 pi radian over 1 revolution. Then only we can cancel revolution with revolution. And now we have to consider this minute. 1 minute over 60 second. So I can cancel this minute with minute. I can cancel revolution with revolution. Finally, you'll get the answer in terms of radian per second. So what will be the answer? 100 multiplied by 2 multiplied by pi value, which is 3.14 over 60, which gives you the value of 10.47. What is the value? 0.47 rad per second. So this is our initial angular speed in terms of radian per second. So better I can write it here, which is equal to 10.47 rad per second. Now we have to find the value of time. So I can just calculate the time here. So for that, again, we have to use these three equations. For this, I think the first equation is exactly suitable. So I'm going to use that equation, which is given by omega final, which is equal to omega initial plus alpha t. And I have to rearrange this equation in terms of t. So I'm going to keep this alpha t here. I'm going to move this initial angular speed to the left hand side. So by that, what will happen? Angular acceleration multiplied by time, which is equal to omega final minus omega initial. And then I'm going to move this to the right hand side of the denominator. Therefore, t, which is equal to omega final minus omega initial over alpha. I'm going to substitute the value. What is our initial angular speed, final angular speed? It's 0. The initial value is 10.47 radian per second divided by minus 2. So what will be the answer? Minus 10.47 over minus 2 gives you the value of 5.235. What's the answer? 5.235. So I can write 5.24. What's the answer, brother, here? 5.24235 second I got. So I can round it to 5.24 second. So this is the answer. Clear? In the second part, we have to find the revolution. That means we are going to find the displacement of the wheel. So how many revolution has the wheel turned during the interval? So we have to give the answer in terms of a revolution. So first of all, I'm going to substitute the value in terms of radian per second value, and then we are going to convert that radian in terms of revolution. So what is the equation? I'm going to use the second equation. What is the second equation? Delta theta, which is equal to initial angular speed multiplied by time plus half angular acceleration multiplied by time square. So here I'm going to substitute the time as this value. Okay, our time is exactly equal to 5.24. Substitute the value here. Initial angular speed is 10.47 multiplied by 5.24 plus half multiplied by, what is the alpha? Alpha is minus 2 multiplied by 5.24 square. So I'm going to find the first part initially. 5.24 gives the 50. 27.40 I got in terms of radian. So delta theta, again I have to write one more time, radian. So here delta theta, which is equal to 27.40 over 2 multiplied by 5. The answer is 4.36. What's the answer here? The answer for the delta theta is given as 4.36. Clear? So this is the answer for this question. Fifth question. An object of mass m, which is equal to 0.9 kilogram, attached to a string is swung at constant speed v, which is equal to 5 meter per second in a horizontal circle of radius r, which is equal to 1.2 meter. So the mass of the object is given. The mass of the object is mentioned as 0.9 kilogram, and what is the speed? 5 meter per second, and the radius of the circle is given as 1.2 meter. First of all, we are going to find what is the angular velocity. So we already studied the equation between the linear speed and the angular speed. What is the relation? The linear speed, which is equal to the linear speed v, which is equal to r omega. So v, which is equal to r omega. I'm going to rearrange this equation in terms of omega. Therefore, omega, which is equal to v over r, and we have the v value as 5 meter per second and the r value is 1.2. The answer is 5 over 1.2 gives the answer of 4.16. 4.17, 4.166 I got. So I have rounded 4.17 radian per second. The second question, we have to find the tangential acceleration. Brother, you have to read the question very carefully. Here it is moving with constant speed. Am I right? If any object is moving with constant speed, if the speed is constant, what is your acceleration? The acceleration of the tangential should be equal to 0. This is the rule. So for second question, our tangential acceleration is 0 is because the object is swung at the constant speed. So if the speed is constant, the acceleration value will be 0. Okay. The third question, what is the centripetal acceleration or radial acceleration? So we already studied the equation centripetal acceleration, which is equal to r omega square, or if you want to use this equation, v square over r both will give the same answer. So for our case, I'm going to use this equation. If you want to use this, you can just go ahead, you will get the same answer. So the R value here is mentioned as 1.2 multiplied by omega. I have to take it from the first question, 4.17, which gives the answer of 1.2 multiplied by 4.17. Oh, it's a square, 4.17 square. So 1.2 multiplied by 4.17 square gives the answer of 20.86. What's the value? 20.87, because 866 I got. And what's the unit for this? The unit for this exactly meter per second square. If you want to use this equation, let's try. So centripetal acceleration, which is equal to v square over r. The v value is 5 square over the radius is 1.2. So you'll get the same answer. 5 square over 1.2 gives the answer of 20.83, but the answer is okay. 20.83 meter per second square. So both equations you can use because our answer here is exactly closer to each other. Clear? And the fourth question, what is the total acceleration? As we already studied in the theory, if you want to find the total acceleration, you have to find the magnitude of both acceleration. Am I right? That means the magnitude equation, what we studied in chapter number 3, vector. So total acceleration, which is equal to square root of the tangential acceleration square plus the centripetal acceleration or radial acceleration square. So centripetal acceleration square, which is equal to square root of the tangential acceleration value 0 plus 20.87 square will give you the answer of 20.87 meter per second square. Clear? The last question, we are going to find what is the centripetal force. As we studied in the theory, it's a Newton's second law. We have to apply the Newton's second law for getting the formula F, which is equal to ma, and here a is the centripetal acceleration. When you substitute the centripetal acceleration in that equation, you will get the centripetal force, which is equal to mv square over r. The mass of the object is 0.9 multiplied by my speed is 5 square over r value is 1.2. So what will be the answer? 0.9 multiplied by 5 square over 1.2 gives the answer of 18.75 Newton. 18.75 Newton. So this will be the answer for the last question. So you have to remember all the formulas what we studied in this chapter. Clear? Sixth question. A 900 kilogram car moving around the circle with a radius of 25 meters. So that means the mass of the car is given as 900 kilogram, and the diagram is given here. And then its radius, because it is moving in the circle, so circle will have the radius. So R value is 25 meter, and the car angular velocity is given, which is omega, which is 0.4 radian per second. We have to find two answers. In the first question, we have to find what is the linear velocity of the car. So as we already studied, the relation between the linear speed and the angular speed, v, which is equal to r omega, and from this I'm going to substitute the value of this r and omega. We will get the linear speed. So what is the value of r? 25 multiplied by omega is 0.4, which gives the answer of, so 25 multiplied by 0.4 gives you the value of exactly 10 meter per second, which is the answer for the first question. Clear? This is not r, this is v. Second question, centripetal acceleration. Again, we have to deal with the same rule. Either centripetal acceleration v square over r you can use, or you can use r omega square. Both will give the same answer. So centripetal acceleration, which is equal to either one of the formula we are going to use. So r omega square I'm going to use here. What is the value of r? The value of r is 25 multiplied by the omega value 0.4 square will give you the answer of 25 multiplied by 0.4 square, the answer is 4. So let's we try it with that formula also. So which is 4 meter per second square. So we try for this also. What is the centripetal acceleration if you use this formula? V square. What is the V square? I'm going to take the answer from the first part, which is 10 square over the radius is 25. So what will be the answer? 10 square over 25 gives you 4. So same answer will come 4 meter per second. Either you can use the first one or second one. So the third question, if the coefficient of static friction between the tires and the road is mu s, which is equal to 0.8, that means the static coefficient value mu s is given as 0.8. What is the greatest speed of the car can have in the circle without skidding? So if the car is moving in the circle without skidding, the car should go. Am I right? So for that, what is the speed the car will take? So in that speed, the car will be safe. Am I right? So we have to find what is the greatest speed. So for this, we have to equate two equation. First one, the static coefficient force, the force due to the static friction. So what is the formula? The static force, the static coefficient, the static friction formula, which is given as mu s Fn. That means the normal force. So here the normal force they mention as N. Either you can use N or Fn. Both are correct. Clear? So your upward force, which is exactly equal to the downward force. Am I right? So in this place of this normal force, what I'm going to do, I'm going to write mu s mg. So this is the formula for static friction. Likewise, if the car is moving in the circle, it will have the centripetal force, which is Fc mv square over r. So I'm going to equate this force with this force. So by that, what will be our new equation? Left hand side of the equation is mu s mg, and the right hand side of the equation is m v square over r. By using these equations, we are going to find what is the greatest speed. So before that, I can cancel the mass with mass, and I am going to rearrange this equation in terms of v square. So therefore v square, which is equal to this r, will come to the left hand side of the numerator. So by that, the equation becomes v square, which is equal to static coefficient multiplied by gravity multiplied by radius. So we have to find the square root. So taking square root on both sides will give you the value of mu s multiplied by g multiplied by radius. So I'm going to substitute the value. What is the value of coefficient value? 0.8, and the gravity value is 9.8 multiplied by the radius is 25 meter. Square root of 0.8 multiplied by 9.8. Angular displacement to the time interval. This is the answer for the first question. What is the answer for the second question? The tangential speed of a point on the rotating object equals the radius from the axis of rotation multiplied by dash. What is that? So they clearly mention this is a tangential speed. What is the tangential speed? It's a relation between the linear speed and the angular speed. V, which is equal to r omega. So they give the questions based on this formula. So what is given? Tangential speed, which is equal to radius from the axis of rotation multiplied by. So this is your radius, which is multiplied by what? Omega. What is omega? Omega is the angular speed. Am I right? Angular speed. Clear? Third question. The acceleration of object moving along the circular path towards the center of the circle is known as, so if any object is moving in the circle, in all the points in the circle, the acceleration always coming towards the circle. Am I right? So what is that? Which is nothing but tangential acceleration or radial acceleration or centripetal acceleration. So I have to write the answer as centripetal acceleration. Okay. The last question. The angular displacement is the difference between the final and initial. What's the formula for the angular displacement? So angular displacement delta theta, which is equal to theta final minus theta initial. So what's the answer? So here theta 2 and theta 1 is the position. Am I right? So what is the answer here, my dear? The angular displacement is the difference between the final and the initial angular position. Clear? Okay, now we have to answer the match the following. Angular acceleration. So what is the unit? Actually here they give 4 answer. So we have to match the correct answer with the question. Actually the angular acceleration formula is alpha, which is equal to delta omega over delta t, and its unit is radian per second square. So we have the answer. This is the answer. Clear? Tangential acceleration. What is the formula for tangential acceleration? Tangential acceleration, which is equal to r multiplied by, what is the relation? R multiplied by omega. So here we have the radius multiplied by angular acceleration. Sorry, r multiplied by alpha. So this is the rule. There is a rule connecting the linear acceleration and the angular acceleration, which is a, which is equal to r alpha. So we have the answer here. So for the second question, this will be the answer. Third question, centripetal force always comes towards the center. Am I right? So we have the answer here. And finally, the unit of angular displacement, as we already know, this is the formula for angular displacement. Am I right? So what is the unit? The unit for the angular displacement is radian. So we have the answer here. So for the final question, this is the answer.